Welcome back to the channel for another exciting experiment using MCP servers for advanced data analytics. What if I told you that now AI agents can help you automate web scraping and web crawling, automate the analysis of dozens if not hundreds of websites to understand their content, how they are linked to each other, or improve their SEO and accessibility. For that, I have built a local MCP server connected to Claude Desktop that I'm using to perform some web scraping, improve the SEO of my website, or analyze the websites of competitors. For that, you just need Claude Desktop, a link to my GitHub repository that I will share in the description, and then you can install this MCP server on your machine and also automate web scraping for your own use. So before I show you the details of the code and how to install it in your own machine, maybe let me show you an example of analysis that I did using my own website, samirsaci.com. First, let's have a look at what happens if you ask SEO analysis to Claude without using the MCP server. So this is the experiment I did here. So I ask for SEO issues on my own website, samirsaci.com. What I did is that I used Claude's web browser version, so that is not connected to my local MCP server. And then, Claude is directly admitting that he's not able to access the website, but then he's just hallucinating and providing some general advices. Then I did the same experiment, but now using my local MCP server. So that I did that on my local machine that is connected to the MCP server. And the first thing that the agent did is to scrape the URL. So using this function, scrape URL, that is built inside the MCP server. For that is using the URL of the website, is asking for loading JavaScript, and we will look at that in the detail of the code. But probably the best added value of this MCP server is that now you have a scrapping tool that can load JavaScript. And if you are a bit familiar with web scraping, which is basically extracting data from websites, loading JavaScript can be very important for some, I would say, dynamic website where the content is not available if you only send an HTTP request. And here's like a parameters, wait seconds. It's the time between two requests that you need to wait to avoid overloading the servers. And then, boom, you retrieve the HTML. So I guess now Claude is using this HTML to provide some relevant information. And for that, he's using another function inside the MCP server to extract some attributes using CSS selectors. And here, let's be honest, I have built this function. I taught the agent how to use the function, but then I didn't tell the agent, because as you can see, my request is pretty simple, what parameters to use. And he's using quite interesting CSS selectors to provide a broad analysis of SEO of my website, looking at the loading time, the structure using the different CSS selectors, and he's providing even areas of improvement. And here was only feasible because I have provided these functions to extract HTML using JavaScript. And here I will explain you later that I'm using Playwright as the library and the tool. The image optimization. To be honest, I was quite impressed by this first analysis, and he's even providing a score. I will share with you the complete prompt so you can have a look of the type of analysis. But anyhow, if you have Claude Desktop on your machine, you will be able to perform the same. So now I will show you the structure of the tool. I will look a bit in the details in the code, then show you how to install it. And then I will show you another example of more advanced SEO analysis. So how the tool is structured. Basically, you start with Claude Desktop. So you can download it for free on your machine. The only limitation you will have if you are using the free version is the usage, because depending on the complexity of the type of analysis, you may use more or less tokens. And to be honest with you, to use the tool at this fullest, I would advise to use Opus 4.1 in terms of models, which is the most advanced model at the time that I'm talking. But you can also try with like simpler model if you don't want to use that many tokens. And then Claude Desktop will be connected to a local MCP server. And to build this server, we are going to use the MCP SDK on Python. And then basically this MCP server will provide to the Claude model the access to multiple tools to perform web scraping. So the first tool is like the input layer. And basically these tools are Python functions that requires input data and that will provide output data. So for the input data, to make sure that the agent provides the right parameters, we have an input layer where you have a list using Pydantic, a list of different parameters that the agent needs to follow to make sure that the functions can be used, where these parameters include the URL to scrape, the CSS selectors, as I showed you in the beginning of the demo, to extract data from HTML, and also some crawling parameters. And here I didn't show you how the crawling is working, but you will have a demo in a couple of minutes. And then you have the core processing parts of the MCP server, which are the functions to perform web scraping and web crawling. And the main function is the web scraper class. And you have two types, two ways to do that. You have the static scraping, where you only send HTTP requests, you retrieve the HTML code, and you extract information. And for that, you can use request or beautiful soup for the parsing. The good advantages is that it's pretty fast. The main issue that you will face is that some content are generated with JavaScripts that you need to run on your browser, on your scrapping tool, and you may not see it if you use these functions. This is why I'm also using dynamic scrapping using Playwright that emulate a Chromium engine that act like a browser. So when you will receive the HTML code, it will load the HTML. The HTML code with JavaScript. It will load the JavaScript. It will extract the additional information, and then it will provide the complete HTML code that you would see in your own browser. And then, let's say that you have extracted, you got the HTML code, either statically or dynamically, then you need to extract information from the HTML code. And this is the data extraction using CSS selectors that you saw in the beginning. And then you have another class or function, actually it's a function of a class, for crawling. So what is crawling is you arrive at the website, for instance, samirsaci.com, you look at the page, you select all the links, you look at the links that are inside the website, so usually like you have samirsaci.com, then the name of the page, you list all these links, you go to each link, and then each time, like iteratively, you look at all the links that are inside the pages. And then in the end, you can extract the whole architecture of the website. Of course, you can use the sitemap for that. But the idea here is to understand, and I did that for my blog, what is the structure, which link is referring to each other to improve the search engine optimization, but also the user experience of readers. And I will show you how it's done in another analysis. And then you have some connection layers. You can find in the description the GitHub repository to install this MCP server locally. I am using Windows for Claude Desktop, and I'm using Windows Subsystem Linux to develop. And you need also to use the Claude Desktop config file, and I will show you how to do that. That will basically help Claude to find the right folder to load this MCP server. And then you have this output layer that can provide structured data. You will see that some function to show the right structure. Sitemaps, I have included this function, but I will not have time to show you it. And analytics dashboards. And here I will show you how, without putting the function inside MCP server, Claude can build very nice dashboards. Okay, so now that we have the structure, maybe we can deep dive in the code. Okay, so now we can go to the code, as you are probably waiting for that. So as I told you, I shared the complete project on my GitHub. You can find it in the description and in the first comment, or you can go to my profile where you can find other supply chain analytics projects with articles, videos, and GitHub repositories. Let's go to the repos, MCP web scraper, and then you find the project that has been committed by my brother because I was using his GitHub and he's my co-founder. So we are mixing sometimes the GitHubs, but it has been written and designed by me. You can trust me. And then inside you have a README where you can follow the different steps to be able to install that in your machine. But maybe I will go to VS Code as we can go more in details and it's maybe more practical. Then what you need to do is just you clone the repo. Then you will open the folder. Then you need to install the UV package manager, and you can use that to download it and install it. Then you can initialize the project, and then you can add the library for MCP server. Don't forget to launch the local environment if it's not done yet. And then you install all the libraries that are in my requirements file. All these libraries will be used for the MCP server and the different functionalities that you are building. When you're done that, so among the libraries, you will install Playwright to render JavaScript. To load JavaScript when you are scrapping for dynamic scrapping. And don't forget to install Chromium. And then you can test. So I have prepared a test file to make sure that it's working on your site. For that, we are using this website. Don't worry, it's a website where if you go there, let me go there. F11. We love being scrapped. What I mean by this, if you train on this website, you will not affect them. Just be respectful in putting some delay when you're scrapping. But basically, this is a website to train your scrapper. So there's nothing wrong with that. And then you test the static approach. So using request, here all the parameters are prepared. You do the same for the dynamic approach. You do the same for the crawler. And here I have put a maximum depth of 2 with maximum 5 pages. It's just to test that the crawler is working. And then normally, if everything is working, maybe I will try it with you. Run Python test local.py. Okay, so the static scrapping worked well. You see, the timing was pretty fast. Dynamic scrapping worked well. Okay, and provides you the HTML length. And then you test the crawler, and 437 pages were discovered. So if you have the same results, that means everything is working on your site. If not, then you can troubleshoot that using the script. So maybe let me quickly go in the code to understand what we're doing here. So first, the most important file is this file where you are defining your webs like an MCP server. I'm calling it web scrapper. I'm introducing some logging, and here you will have a file at the root where you find all the logs. It's quite important to troubleshoot because you will maybe face some issues. Maybe let's go. So here we are importing all the libraries for the Python SDK of MCP server called FastMCP. Some logging here, Pydantic to ensure that for the definition of the parameters. We are importing the function web scrapper and all the different models for the input parameters. Maybe let's start with that. So these are Pydantic classes to ensure that the agent is using the right parameters. So you have one for the scrapping method. It can be static or it can be dynamic. Static, as I told you, is using request, where you don't load the JavaScript. Dynamic is more like dynamic, where you load the JavaScript. Then you have the scrapping request. What do you have in the scrapping request? The URL, the decision of loading JavaScript or not. Let's not forget, the agent will select these parameters. So he will decide itself if he wants to load the JavaScript or not. Definition of some timeout. So what I mean by that, if the loading is not done by a certain time, you stop everything. Waiting time. So if you are scrapping multiple pages, what time do you wait between 2 pages? The headers, these are some parameters, the header. So when you are sending a request to the website, how you are showing yourself as a browser, what type of browser. These are some scrapping parameters. And same for the user agent. Then the response. So here, how you format the response. So you retrieve the URL, the HTML, that's the most important thing. The status code, in terms for troubleshooting if there are some errors. The type of method. So the method is dynamic or static. The loading time. If you remember well, the first analysis that we did, the agent analyzed the loading time. So quite interesting here. If there were some potential errors and the headers used. Why do we need error and headers? Because maybe the error can be linked to the header. That's why I did that. Here, the element selector. So when you are extracting information from HTML, you are going to use CSS selectors. This is the Pydantic class to select the right parameters. Also multiple, because you can have multiple batch, as you saw in the initial analysis. Then the extra request, that is using the HTML and the selectors. And then the extract response. So here, what type of data that you are extracting and if there was potential errors. Here, this variable can contain the message error that was being retrieved by request. So the agent knows why it couldn't retrieve the data. And then, so all these Pydantic classes are used for this web scraper function that you are initializing using the session ID. Why we use the session ID? Because later, probably you would like to productize that. So it's a way to manage users. And also, let's imagine that you have a fast API microservice, you are going to launch the Playwright browser, like to perform some scrapping. At the end of the scrapping, you want to shut it down. And that's why you have the session management and this function cleanup that will close the session. And the scraping function. So this scraping function is like basically wrapping multiple sub-functions depending on the type of scrapping you want. So the method that we call here. If the method is dynamic, then you put this Boolean variable if this Boolean variable JavaScript loading that is an input parameter is at true, it's dynamic if not static. Then I had some logging message to inform us, what type of scrapping has been used. If it's dynamic, you use the function scrap dynamic. If not, you use the function scrap static. Here some error management. Always use the traceback. You will face many issues depending on the website. Probably that your MCP server will be different from mine depending on the usage. Anyhow, so here you have two functions, dynamic, static. The static one, as I told you, very simple, is using request. And so the response depends on the request URL, the headers, and the timeout. These are the parameters initially. And then you get the scrapping response, some error management. Here, if you have an error, you want also to return the status code. And you want to return a response too, but now instead of having HTML content, you have the errors. Why I'm doing that? It's for the agent, so he can troubleshoot and explain to the user why the scrapping failed. Same for dynamic, but now we are using Playwright. And then you have, at the end, the functions to extract the different elements. So if you remember well, if you're not familiar with scrapping means receiving some HTML after static or dynamic loading. And then you want to parse the elements. And for that, you are using Beautiful Soup. It depends on the different selectors. Here, you will see that sometimes the agent is pretty smart to use the right selectors. But if you see that the agent is struggling, you can also help depending on the complexity of the page that you are using. Here we have a function for multiple elements. Here we have a function for single elements, like a single selector. And here the last function is the crawling. And as I explained you, crawling is basically connecting to a page, looking at all the links, if there are internal links, going to each of them. And then you do that until you have covered the whole website. For that, you have multiple parameters, the number of maximum pages, the maximum depth. If it's the same domain, of course, because this is what we call crawling, and then the delay between the two requests to overloading the server. Great, so now that we have defined the class for scrapping and crawling, we can go have a look at the different tools that we have available for the agent. The first one is the scrapping tool. So based on the URL, the method, if you want to load JavaScript or not, and the waiting seconds, you will extract HTML, the HTML of a specific page. How the agent is able to do that, thanks to this docstring, which is a kind of a prompt that will explain to the agent how to use the tool. You have a second tool, which is extract data. So now that you have the HTML code, how to extract the right information. And for that, you are using CSS selectors. Here again, you have a docstring. To be honest with you, I was not that much concise. I have asked Claude to write good docstring for himself or itself to be able to understand the functions. And as I don't count that much the tokens, probably you have some room for improvement. This will extract the right information and provide the data as results. Here, extract first. So this function is basically to extract the first element that is matching a specific CSS selector. I was advised to provide this function, and it was used for one of my case study that I haven't shared here. Here, batch scrap int, for instance, if you are giving multiple websites. So here, it's a way for the agents to know how to orchestrate that in the most efficient way. And then you have the tool for crawling. So here you provide an initial website, the number of pages, the max depth that you want to go, and if you want to keep the same domain. And then some documentation. So here, it's a kind of a prompt to explain all the potential usage that you can have of this MCP server. I think we're good. So now we can go to see a more advanced case study. So before leaving you to test this tool on your own machine, I wanted to share with you an example of analysis that I did for my own website, samirsaci.com, using the crawling function. So here, instead of asking to analyze a specific page, I wanted the tool to crawl among the different pages. And I think I have up to 80 to 85 articles in my blog, to understand the structure and provide me some advice on improving the search engine optimization. So for that, I just asked a very general question. Please help me to crawl my blog. It did that. How it did? It decided to have a max depth of 3, which is okay, but let's not consider that I'm sharing a lot of articles between each other. So, and the maximum page of 50, which is not covering the whole website. And of course, is using the function same domain only. It discovered up to 222 pages, 50 pages crawled, which was enough actually. I'm not sure if it's covering the whole website. And then it's providing a very nice, so the loading time here, I think is the average loading time, the different links extracted. And here, what is quite interesting is that it provides some KPIs that was not directly asked in the initial request. It provides visibility on the site structure, the different topics. So here, probably he understood that these are the main topics based on the fact that these are, I would say, titles of pages. Here, I don't know why he's considering these articles popular, but it's probably because they are mentioned a lot in some articles, I don't know, and all the technical details. So yeah, no issues in terms of loading. And then he's asking me for more like advanced analysis. So it's what I did. So I asked to move the limits to 150 pages, and I gave a kind of an open request to say, I want to understand how articles are referring to each other, because I want to make sure that if a reader arrives in my blog, it will go in different articles. And I ask for this type of analysis. And when I say analysis, I expect the agent to generate an AS graph, like a dashboard or something. And usually, like Claude is doing that. So that's what he did. He changed the number of pages. He kept the same depth. And then he crawled 88 pages. So 88 pages were enough to cover the whole website. Then he analyzed data. And I think here he didn't use any functions. He used code to do that, JavaScript code, which is quite interesting to analyze the JSON. And then he built a dashboard. And this is where you see the added value of Claude. And to be honest, I was quite impressed by this dashboard. So you have a kind of overview, the number of articles, the number of topics, the number of average links per page, which is a KPI that is very interesting for me. Some overview. I will not enter details, but he finds ways to understand the different clusters. And these are the categories in my blog, but I never explained that to him. Yeah, per article, the number of inbound links and outbound links, this is a parameter that I had in mind when I was asking for this analysis, and he did that. He provided a ranking, which is quite good. So for instance, I know that my best performing article is that one, Sustainable Business Strategy with Data Analytics, and which is not a surprise for me because it's referring to supply chain, sustainability, and business. And then, I could improve others like data quality, which is supposed to talk about data, where I probably should refer to more articles. And then we can look at the linking pattern. And here, look at the series of articles. Like inside the series, the articles are referring to each other. So inventory management, usually this is one, you have multiple type of inventory rules, and I'm referring to each other in each article by topic hubs, by cross-reference. To be honest, this kind of analysis is quite complete, and the recommendations. And here I go directly in the opportunities, maybe increase the cross-topic linking. So what I mean by this is that inside the same topic or like same hub, you have like inter-references, but maybe I should go beyond that. And update older articles, so add links to new or related content, which actually it's a good advice. Anyhow, so I hope this gave you enough visibility and enough, suspense to try the tool inside your own instance, like computer or server. If you have any question, feel free to use the comment section as a forum. I will try to answer them. And if you have some improvements in mind, don't hesitate to use the GitHub repo for that. And see you for the next video.